Come back. Let us consider rational numbers. Good. Rational number is not something that is strange or new to you. It is something that you've been hearing about. What exactly do we call rational numbers? Good. The word rational comes from the word ratio. And as far as ratio is concerned, we use this symbol to represent ratio. And you have been told that this symbol can be represented as division. So it means if I write 2 to 3, that is 2 ratio 3, it means this is the same as 2 divided by 3. Another way of writing 2 divided by 3 is to write it as 2 over 3. So where are we coming from? We come from ratio, becomes division, division now becomes fraction. It means ratio, they just added the word, they turn it from noun to adjective to become rational, from ratio to rational. Good. It means any number that is rational is a number that can be written in this form, which is fraction. So I have defined it. It means a rational number is any number that can be written in fraction. Good. You can pen that down. You can write it down. A rational number is any number that can be written in fraction. Good. Most times in advanced mathematics textbook, they will want to scatter your head. They will now say a rational number is any number that can be written in the form A over B. Sorry, A over B, what does it mean? Is it not fraction? Don't let them confuse you. But they will now put additional information where A and B are integers and B is not equal to 0. This is where you need to calm yourself. You need to learn more. A and B are integers. What do we mean by integers? That is whole numbers. Numbers that are not decimal or fraction, like 1, 2, 3, 4, 5, 6, and so on. And B must not be equal to 0, because if B is equal to 0, the whole of the fraction becomes undefined. Good. So that's what rational number is. So we can have several examples like 2 over 3, 5 over 8, 7 over 25, and so on. We can even have bigger number on top like 9 over 3, 9 over 2, 5 over 3, and so on. So all of these are rational numbers. But let's see the different cases of rational numbers. Now, rational numbers can either be integers. Integers are rational number. For example, ordinary 2 is rational because 2 can be written in fraction. You can write it as 2 over 1. You can see this is rational like this. So if you write 5, 5 is integer. 5 is the same thing as 5 over 1. You can have minus 8. Minus 8 is the same thing as minus 8 over 1. It's still rational. So this is case 1. Case 2 of rational number, we have terminating decimals. Terminating decimal, examples of terminating decimal is 2.5, 3.8, 1.573. So far the decimal ends at a particular point. 2.5, the stopping point is 5. 3.8, the stopping point is 8. 1.573, the stopping point is 3. So all of these numbers are rational because we can write them in fraction. 2.5 is the same thing as 25 over 10. That's then 3.8 is the same thing as 38 over 10. 1.573 is the same thing as 1573 all over 1000. How did we get that? So 25, 2.5, remove the point, write 25. Then write 1 and add the number of digits that you have after the decimal point, turn it to 0. because we have only one number after the decimal point here. That's why we have only 1 0. Here, only one number, we have 1 0. Here, 3 numbers, we have 3 zeros. That's, you can see that each one of them has been expressed as fraction. So they are also rational numbers. Then the third case is recurring decimal, non-terminating recurring decimals. Let's see that also. Case 3 of rational numbers, unterminating recurring decimals. So let's see examples of that. Numbers like 0.11111, let's say the one continues like that till Jesus comes. This can be written as, in a short form, you can write it as 0.1 and put dot on top of it. This indicates that the one is repeating. Or you can write it as 0.1 bar. So to convert this can be converted to fraction as 1/9. You can confirm that with your calculator. This is a trick of converting. Even if you have 0.5555, let's say the 5 continues till Jesus comes, the result is going to be 0.5 dot, or you write it as 0.5 bar, then my result will be 5/9. So you can use your calculator to confirm it. I will teach the complete solution of this in subsequent video. But if the repetition is more than one number, for example 0.3131313131, and it continues like that, what I will do, I will observe the repeating digit. How many are they? Just 2. That's 3 and 1. Then I will divide it by, how many digits do we have? Just 2. I will divide it by 9 and 9. Because we have 2 numbers repeating, I will have to use 2 9. Because we have one number repeating here, I divide by 1 9. Because I have only one digit repeating here, I divide by 1 9. So what if we have 3 numbers repeating, like 0.185, 185, and so on? The result will be 185 divided by 999. Even if you have 4 digits repeating, you divide by 4 9s. If you have 5 digits repeating, divide by 5 9. That's the simple trick of dividing. And if you use your calculator to confirm it, it's going to give you the right answer. So these are the 3 cases of rational numbers. It's always good to use your calculator to confirm some, because there are some ambiguous cases, like the case of trigonometry function or roots. For example, sine 30. Sine 30 is the same thing as 0.5. You may be thinking that all trigonometry will lead to irrational. They are always, at times, some of them can be rational. So, and this can be written as 1/5/10, which is 1/2. So, we'll explain more about this in subsequent video. Thank you.